Welcome to Saxon Algebra 1, 3rd edition, Lesson 81. Now, this lesson is going to consist of several things. First, graphical solutions, how you can graph the solution of an equation or a set of equations, and then inconsistent and dependent equations. All right, so how do you use a graph to solve systems of equations, like this, for instance? Here we have two equations. Now normally you would use either substitution or elimination, but there is a third way that you can do this and solve for x and y. And that would be when you graph each one and then find the place where they intersect each other. Alright, so I have to get this in the form of a line, which is y, and I solve. So you see I move this negative 2x over here, and then I have negative 3y equals negative 2x minus 6. Divide everything by negative 3. Now I've got y equals, and that was the goal, y equals 2/3 x plus 2. Now 2/3 you know is our slope, 2 is our y-intercept. So we're going to plot this line on our graph. We're going to start at 2, and we're going to go up 2 over 3, or we could go down 2 over 3 to the left. And then we have this line. I'm going to do the same thing with x plus 3y equals negative 3. I'm going to move this x onto the other side, and then I have 3y equals negative x minus 3. When I divide all sides by 3, I get y is equal to negative 1/3 x minus 1. So now I'm going to draw this line. I'm going to plot it, the points. I'm going to start at negative 1. From there, I'm going to go down 1 over 3, or I can go up 1 over 3. Let's see, up 1 over 3. When I draw this line, I'm going to see that the solution to x and y is actually x is negative 3, and y is 0. So this is going to be negative 3, negative 3, 0 is where those two meet. Okay, in these two examples, you'll see that we have two different equations. The first thing we would need to do in this top example is get this into line form, correct line form. So we would say 2y equals negative 2x plus 6, and then if we divide everything by 2, that would make that line y equals negative 1x plus 3. And in this one, let's move this 4x, and we'll have negative 6y equals negative 4x. Sorry, let's make that a little clearer. Negative 4x plus 12. Divide by negative 6, negative 6, negative 6, and we get y is equal to 2/3 x minus 2. So these are actually the lines that have been graphed for you for these equations. And you see that they are going to intersect. They do have an intersection point, 0.30. That is the solution to these two equations. In this example here, you've got y equals 3 over 2x plus 2, and equation B, y equals negative 1/2 x minus 2. When you graph those points, and you draw your lines, you're going to see that these are also, they're called consistent equations because they do have a solution, a single solution. So we'll talk more about that in a minute. The intersection point of these two lines is right here, and that is, let's see, on the x it's -2, and on the y it is -1. So that would be the intersection or the solution to these two equations. So let's look at some ways that we can graph and find solutions to systems of equations, which means two or three equations. So if I graph y equals 2, then that's going to tell me that it's going to touch the y-axis right here, and this is going to be just a simple horizontal line going both ways. Y equals x. Well, if we put this in line formula, we could say y equals 1x plus 0. So if we start at 0 and go up 1 over 1, and then up 1 over 1 again, up 1 over 1 again, or we could go down 1 and over to the left and continue that pattern. Sorry. And then we connect the dots and draw our line. And you're going to see that the answer is going to be right here where the two lines touch each other. So that would be 2, 2. So that would be the solution to these two equations. All right, let's do some more. Okay, on this one, the first equation says y equals x plus 2. So we start at our y-intercept, which is 2. We go to 2 on the y. From there, x is 1x, so that means 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. And then we can also do from this original point down 1 over 1 to the left, because two negatives make a positive. And then down 1 over 1 and down 1 over 1. So when we connect these dots, when we connect these dots, we're going to get a line that looks something like this. Oh well, straight as I can get it. All right, and then y equals x minus 1. So our y-intercept is -1. We'll start here on the y-axis, and we will go up 1 over 1, up 1 over 1, up 1 over 1. Or again, we could go from our origin, we could go down 1 over 1, down 1 over 1. And then when we connect these dots, we're going to see that we have a line that continues on like this. Okay, so in this one, we have parallel lines. And in parallel lines, they never are going to touch. So that means that there is no solution to this system of equations. So we call this inconsistent equations. So when you have parallel lines, you can call that an inconsistent equation. The second portion of Lesson 81 is about inconsistent, consistent, and dependent equations. So you can see that consistent equations are two equations that touch in at least one point. Now, consistent and independent, these are the ones that we see most often, and they will have one single point where they intersect. So it's intersecting lines, and there is only one solution, one point where they cross. Consistent and dependent is basically it's the same line with two different looking equations. And this one can have infinitely many solutions because everywhere on these two lines, they're going to continue to touch everywhere, and every one of those would be a solution. Now, what is inconsistent? Inconsistent will always be parallel lines, meaning that they are never going to touch, so there cannot be a solution at all. So no solution. So when you see parallel lines, you're going to think inconsistent and no solution. When you see two lines that line up on top of each other, those are dependent equations, and the ones that, like I said, we see most often are consistent independent. So let's go ahead and work your practice problems. In A, we are to find the solution, and it tells you that we can check by substitution. Y equals x minus 1. Well, we start on negative 1, and x means 1x, so we go up 1 over 1, up 1 over 1, up 1 over 1, or like I said, down 1 over 1 to the left, two positives. Alright, and we're going to draw this line and connect all of these dots, and that is our first line. Alright, the second one is y equals negative 2x plus 5. So we're going to start up here at positive 5, and we're going to go from there down 2 over 1, down 2 over 1, and there you see we are going to have a solution, and then down 2 over 1. I'll do it one more time. Alright, so we're going to connect this line, these dots, and you can see that this is the solution. So the solution would be it's 2 on the x and 1 on the y. So 2, 1 is the solution to these two equations. In B, we have y equals x and y equals 4. Now, remember we did one like this before, and we said that y equals x means like y equals 1x plus 0. You can always do that. And y equals 4. Y equals 4 means it's going to touch on y on positive 4, and it's going to be a horizontal line all the way across. And then y equals 1x plus 0, we're going to start at our origin point of 0 and go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and I'll do it one more time, and then we're going to connect these dots, and we see that the solution to these two is going to be 4, 4. That's where they meet. 4 on the x, 4 on the y. 4, 4. Okay, C asks us to consider these two equations, x plus y equals 7 and x plus y equals 9, and then determine whether they are consistent, inconsistent, or dependent. So the first thing we're going to have to do is graph them, and I have gone ahead and put them into line formula form. And so we have on the first one, y equals negative 1x plus 7. So for that, we're going to have to start at our origin point of 7. And from there, we're going to go down 1 over 1, down 1 over 1, down 1 over 1, and down 1 over 1. And then we're going to connect these dots. Well, that didn't look too good, did it? We'll try that. All right, and then the second equation is y equals negative 1x plus 9. So from there we're going to start at positive 9 and go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. We'll do it again. And then we'll connect these dots. Sorry, I'm having a hard time getting on the line here. Anyway, you can see that these two are parallel lines. So if they are parallel lines, what did our lesson tell us? They are going to be considered inconsistent equations, and they do not have a solution at all. They are never going to touch, and that means where they touch is the solution. All right, long lesson, but we got through it, and unfortunately 82 is going to be another lengthy lesson, but we'll get it. These are very important lessons. Again, as I have said before, if you need further explanation, please go to yaymath.org. That is YAY math.org, and choose the Algebra 1 videos, and then scroll down and look for graphical solutions or something along that line. Mr. Adhoot is extremely gifted math teacher and can probably do a much better job than me. All right, I'll see you next time.